Hello dear kids, welcome back to our social studies class. See, in our daily conversations, we often use or discuss a cold morning, a windy day, a cloudy sky, a sweltering afternoon or a warm evening. So, all these refer what? To the weather conditions of a particular place at a particular time. So, today in our chapter is all about elements of weather and climate. So, today our chapter is all about elements of weather and climate. So, do you know what is weather and climate? So, weather and climate are at the very center of our existence. The influence our ways of life, the clothes we wear and the food we eat, the houses we live in and the crops we grow and so on. So, what is weather? Yes, weather is the condition of the atmosphere at a particular place over a short period of time. Weather is the condition of the atmosphere at a particular place over a short period of time. It is not constant and keeps changing. So, it may change from day to day or within the same day itself. Morning it may be rainy, afternoon it may be cloudy, there can be changes. So, and what is climate? Climate refers to the average weather conditions of a large area over a long period of time, maybe 35 to 40 years. This is the difference. So, climate means its average weather condition of a particular place or area over a large period of time. So, the climate of a place is permanent and does not keep on changing, it is permanent. So, in this chapter we will discuss more about the elements of weather and climate. And do you know what are the main elements of weather and climate? Yes, they are temperature, pressure, then winds, humidity, precipitation, then sunshine and cloud cover. So, let us see what is the temperature of the atmosphere. Yes, the temperature of the atmosphere can be defined as the degree of hotness or coldness of air. Okay. The instrument used to measure temperature is called the thermometer. So, which is the instrument used to measure the temperature? That is thermometer, do not forget. Then the temperature of air is measured in degrees. Okay. The two most common thermometer scales are the Fahrenheit and Celsius or centigrade. The sun is the main source of heat and light on earth. Okay. So, the earth is very small compared to the sun and it is 150 million kilometers away from it. Okay. So, therefore, it receives only 1 in 2 billion parts of the total radiation of the sun. Okay. So, do you know what is solar radiation? The heat energy radiated from the sun is known as solar radiation. Okay. So, the amount of solar energy received by the earth is called insolation. The amount of insolation reaching the earth's surface depends on inclination of the sun's rays and the duration of daylight. So, it varies not only from one place to another but also with the time of the year. And let us see the next one, global distribution of temperature. So, what is global distribution of temperature? As we all know, the earth has been divided into 3 heat zones according to the amount of insolation received. Okay. So, these are this area, this is torrid zone, north temperate zone, south temperate zone, north frigid zone and south frigid zone. So, total 3: torrid zone, temperate zone and frigid zone. Okay. So, look at the diagram of the heat zones and note their boundaries. Let us see. The torrid zone receives vertical rays of the sun from here. So, it receives the vertical rays of the sun. So, it will be the hottest zone, right. So, while the frigid zone, look at these two, look at the amount of the heat, the distribution of the heat. This is very less, direct, and this is slanting, extremely slanting, right. So, the frigid zones are the coldest as they receive extremely slanting rays of the sun, extremely slanting rays of the sun. And what about these two temperate zones? Temperate zones are neither too hot nor too cold because the sun rays are slanting, not like of this torrid zone. Okay, this is what the global distribution of temperature. Got it? Good. And now let us see what are the factors controlling temperature. See, the temperature of the atmosphere is not the same everywhere. We know it. It largely depends upon the amount of insolation received by a particular place. The various factors which control the temperature of a place are latitude, altitude, distance from the sea, then winds and ocean currents. We have already learned it in the previous class, but still we can have a recap. So, the first one is latitude. Let us see. The equator and the regions near the equator receives vertical rays of the sun. The equator and the surrounding areas receives the vertical rays of the sun. See, as we move away from the equator, what will happen? So, as we move away from the equator towards poles, due to the curvature of the earth, curve shape of the earth, the sun rays become more and more slanting. These areas will be more and more slanting, right. Then therefore, places near the equator have high temperature and the temperature goes on decreasing from equator towards poles, towards North Pole and South Pole, right. Good. And the next factor is altitude or height above sea level. Here you can see the diagram. The atmosphere is not directly heated by the sun, but indirectly by the heat of the earth. Okay. The atmosphere is not directly heated by the sun, but indirectly by the heat of the earth. See, close to the earth's surface, the layers of the air, here you can see close to the earth's surface, the layers of the air are dense. They are dense, very thick, and they also contain a lot of water vapor and dust particles which absorb the heat. Okay. So, as we move on to the higher altitudes, while we are moving up, the layers of the air become thinner. It is not so thick, it is very thin. Okay. So, as we move on to higher altitudes, the layers of the air become thinner and they contain lesser amount of water vapor and dust particles. So, the heat absorbed here is less. So, therefore, the temperature decreases with increase in altitude. Very important, the temperature decreases or reduces with increase in altitude or height. So, this explains why hill stations are colder than plain lands. Understood? Good. And next factor is distance from the sea. See, land gets heated up and cools down faster than the sea. This is a fact. So, land gets heated up and cools down faster than the sea. So during the day, what is happening? During the day, the land is warmer than the sea. So what will happen then? The hot air over the land becomes lighter. The hot air becomes lighter and rises up. Then what will happen? The cool air from the sea takes its place. Great. So listen, the hot air over the land becomes lighter and rises, and cool air from the sea takes its place. This is known as sea breeze. You can say the wind which blows from sea to land is known as sea breeze. Okay. At night, the sea is warmer than land. The sea is warmer than land. Then warm air over the sea rises. Okay. The warm air over the sea rises and it is replaced by the cool land breeze. Just opposite. Okay. It is replaced by the cool land breeze. So this is known as what? Land breeze. The wind which blows from land to sea is known as land breeze. Okay. So land and sea breezes have a moderating influence on the temperature of the coastal areas, and so they have a maritime or oceanic climate. So places situated far away from the sea have extremes of temperatures and thus experience continental climate. And the next factor that influence is winds. So winds blowing from warmer areas raise the temperature of the place over which they blow. So winds blowing from warmer areas raise the temperature of the place over which they blow, while winds blowing from cooler areas lower the temperature. Okay. Like if you stand in front of a fire, the wind which is coming from air, that fire will be very hot. The same way you just go and open the refrigerator, the cool breeze you will feel. No, this is what here. The wind which blowing from the warmer areas rises the temperature, and while the winds blowing from the cooler areas lower the temperature. And the next point was oceanic or ocean current. Okay. Then warm ocean currents increase the temperature of nearby coastal areas, and while cold ocean currents decreases the temperature. Just like I said about winds. So not only winds and ocean currents, relief, then slope of the land, clouds, soil and vegetation cover are other factors which influence the temperature of a place. Okay. And let us move to the next topic, that is atmospheric pressure. See, listen carefully. Air exerts pressure on everything on the earth's surface. Exerts pressure on everything on the earth's surface. This happens because the upper layers of the atmosphere rest on the lower layers. One layer, lower layer, then the next layer, then the next layer, like that. So upper layers of the atmosphere rest on the lower layers. So atmospheric pressure can be defined as the force exerted by a column of air due to its weight at a particular place on Earth's surface. Okay. And the instrument used to measure atmospheric pressure is called a barometer. Remember the name of that instrument which is used to measure atmospheric pressure, that is called a barometer. So the unit in which air or air pressure measured is called millibars. The unit in which air pressure measured is millibars. Then there are two kinds of barometers, mercury barometer and aneroid barometer. Okay. And let us see what are the factors affecting atmospheric pressure. See, atmospheric pressure on the earth or Earth's surface is not uniform. The pressure varies. So it varies from one place to another and time to time. So let's see the factors. So the factors which affect atmospheric pressure are: first one, altitude; second, temperature; and third, water vapor. Okay, let's see the first one, altitude. So what is altitude? How it affects the pressure? So air pressure is the highest at sea level. So air pressure is the highest at sea level and decreases with altitude. So as one goes up, what will happen? The density of air decreases, and so does the pressure exerted by it. The same way. So as one goes up, the density of air decreases, and so does the pressure exerted by it. Okay. And next one was that is temperature. When temperature increases, the air expands and density decreases. Remember, when temperature increases, what will happen? The air expands and the density also decreases. As a result, air becomes lighter and exerts less pressure. In contrast, what will happen? In cold air is dense and heavier. Remember, cold air is always dense and heavier. Therefore, it exerts more pressure. Okay. And the last one, that is water vapor. So air containing more water vapor is lighter than air which has little or no water vapor. Another fact. So air containing more water vapor is lighter than the air which has little or no water vapor. So thus the moist air exerts less pressure than dry air. Okay, good. Now we are moving to one important topic, that is permanent pressure belts. Okay, it's easy to understand, but you have to be very careful. Okay, let's see. The horizontal distribution of atmospheric pressure is not uniform all over the globe. It's not uniform. So it varies from one place to place, and mainly according to the temperature, according to the decrease and increase in temperature. So it is, however, greatly modified by the rotation of the earth. It is just because of the rotation of the earth. So there are 4 major pressure belts on the earth. There are 4 major pressure belts on the earth. Listen me carefully and study carefully. So here you can see the first one, the equatorial low pressure belt. The equatorial low pressure belt. Look at the degree, 5 degree north to 5 degree south. This is what the first belt, equatorial low pressure belt, 5 degree north to 5 degrees south. And the second one is the subtropical high pressure belt. Okay, subtropical high pressure belt. Both sides you can see, both hemispheres, here and here you can see subtropical high pressure belt. So look at the degrees, 30 degree north to 35 degree north, and here also 30 degree south to 35 degree south. Okay, and the third one, the subpolar low pressure belt. So it can be both hemispheres, like subtropical high pressure belt. So here also subpolar low pressure belt in north and subpolar low pressure belt in south. So commonly we can make it together. So the subpolar low pressure belt, 60 degree north to 65 degree north in northern hemisphere, and come back down 60 degrees south and 65 degrees south in this southern hemisphere. Okay, and the last one, the fourth one, the polar high pressure belt, here and here, both sides, polar high pressure belt. So 90 degree north and 90 degree south. Got it? So you have to be very careful while studying there are mainly 4 types of pressure belts, and the first one is the equatorial low pressure belt, then the subtropical high pressure belt, and the subpolar low pressure belt, and the last the polar high pressure belt. And let us see about winds. Winds. The horizontal movement of air is called wind. Definition of wind. Horizontal movement of air is called wind. Winds always blow from high pressure area to low pressure area. This is another one fact, don't forget. Winds always blow from high pressure area to low pressure area. So they are named after the direction from which they blow. The direction of wind is measured by a wind vane. Remember, the direction of the wind is measured by a wind vane, while the speed of the wind is measured by an anemometer. Okay, the speed of the wind is measured by an anemometer. And let us see another one, that is planetary winds. Okay, so what do you mean by planetary winds? So these winds blow in the same direction throughout the year. Okay, very simple. Planetary winds blow in the same direction throughout the year. Thus, they are also called prevailing or permanent winds. The planetary winds are also known as prevailing or permanent winds. They are of 3 types: the trade winds, the westerlies, and the polar winds. Let us see the first one, the trade winds. Trade winds blow from the subtropical high pressure belt to the equatorial low pressure belt in both the hemispheres. Look at here the first one. So this is what trade winds, this arrow mark. So it blow from the subtropical high pressure belt, to the equatorial low pressure belt, from here to here and here to there, that is in both the hemispheres. So this is known as what? The trade winds, from subtropical high pressure belt to the equatorial low pressure belt in northern hemisphere and also in the southern hemisphere. And the next one is the westerlies. The westerlies, it blow from the subtropical high pressure belt to the subpolar low pressure belt in the both hemispheres. Let us see. It blow from the subtropical high pressure belt to subpolar low pressure belt. Subtropical high pressure belt to subpolar low pressure belt in both hemispheres. Here also it is happening, same. And the third one, that is the polar winds. It blows from the polar high pressure belt to the subpolar low pressure belt in both hemispheres, means polar high pressure belt to subpolar low pressure belt. Here and here, both sides you can see. So this is what? The planetary winds of the world. And what about periodic winds? Periodic winds. So it blows in a particular direction during a specific time of the day or season. Remember, periodic winds blow in a particular direction during a specific time of the day or a season. So the monsoon winds, also called seasonal winds, are the best example of periodic winds. Okay, the monsoon winds are the best example of periodic winds. Then land and sea breezes. Okay, land and sea breezes and mountain and valley breezes are also examples of periodic winds. And next one, local winds. Local winds blow over a small area for a short duration and are associated with weather changes. Local winds blow over small areas for a short duration, it's not for a long period of time, and are associated with weather changes. Okay, so they are known by local names such as Lou. So, local winds in India is known as Lu, then Chinook in North America, then Foehn in Europe, and Harmattan in Northern Africa, and Mistral in the Northern Mediterranean coast. Okay. And the next, variable winds. So, variable winds blow for a short duration and change their speed and direction frequently. So, variations in the name itself you can identify variable winds blow for a short duration and change their speed and direction frequently. Cyclones and anticyclones are examples of variable winds. So, when a strong winds blow in a spiral motion from the surrounding high pressure area to low pressure area at the center, that is known as what? Cyclone. Okay. So, it is associated with heavy rain and it is very destructive. Okay. But in an anticyclone, what will happen? Gentle wind blow out from high pressure area to the surrounding low pressure areas. So, it is associated with fine weather. Okay, good. And let us see what is humidity. The amount of water vapor present in the air is called humidity. We know it. The presence of water vapors in air varies greatly from place to place and also with time. Okay. The most important factor that affects humidity is temperature. Remember, the most important factor that affects humidity is temperature. Then high temperature causes more evaporation. Okay. The high temperature causes more evaporation which results in high humidity, while low temperature results in low humidity. Okay. High temperature causes more evaporation and low temperature results in low humidity. So, the instrument used to measure humidity, do you know which is the instrument used to measure the humidity? Yes, it is called a hygrometer. It is called a hygrometer. Okay. The humidity of air is expressed into two ways. Okay. First one is absolute humidity and the second is relative humidity. Let us see what is absolute humidity. So, absolute humidity is the actual amount of water vapor in a given volume of air at a given temperature. Okay. It is measured in grams per cubic meter. So, it is the actual amount of water vapor in a given volume of air at a given temperature. Then what is relative humidity? Same, the ratio between the actual amount of water vapor present in a given volume of air at a given temperature and maximum amount of water vapor which the same volume of air can hold at that temperature. Okay. So, it is expressed as a percentage. It is not in degrees or cubic meters. It is expressed as percentage. Okay. And do you know what is condensation? Let us see what is condensation. So, when the temperature of a saturated air falls, the water vapor in it gets converted from the gaseous state to the liquid or solid state. When the temperature of the saturated air falls, the water vapor in it gets converted from what? From the gaseous state into the liquid or solid state. This process is called condensation. So, different forms of condensations are clouds, dew, frost and fog. And what is clouds? Clouds are formed when water vapor in the air condenses around dust particles into tiny droplets of water. They are mixing into the tiny droplets of water. On the basis of the their appearance and the height at which they occur, clouds can be classified into cirrus, stratus, cumulus and nimbus. Types of clouds are cirrus, stratus, cumulus and nimbus. And what is dew? Dew is formed when moist air comes into contact with a cool surface. When moist air comes in contact with a cool surface such as grass and condenses into droplets of water, tiny droplets of water, that is known as what? Dew. And what is frost? Frost is formed when dew occurs in the form of ice crystals. Okay, when dew occurs in the form of ice crystals, that is what? Frost. And fog? Fog is formed when condensation takes place in the lower layers of the atmosphere. When condensation takes place in the lower layers of the atmosphere, close to the land surface or above water bodies, that is what? Fog. Good. So, let us see what is precipitation. Continuous condensation of water vapor in the air. Continuous condensation of water vapor in the air results in the formation of minute droplets of water. Okay. When these droplets join together, they form bigger drops which become too heavy to float and start falling down. Okay. So, this process is called precipitation. I am repeating it again. Continuous condensation of water vapor in the air results in the formation of minute droplets of water. When these droplets join together, they form bigger drops which become too heavy to float and start falling down. So, this process is called precipitation, very important. Okay. So, there are 4 types of precipitation. First one is rain, next snow, then sleet and hail, of which rainfall is the most common. So, rainfall is the most, other things are there, what? Rain, snow, sleet and hail. So, let us see what is rainfall. See, when the condensed water vapor in the clouds falls down in the form of water drops, it is known as rain. Yes. So, when drops of rain are very small, it is called what? It is not rain, it is drizzle. Okay. When the drops of rain are very small, and it is called drizzle. So, the instrument used to measure rainfall is called a rain gauge. Okay. It is a rain gauge, and there are 3 types of rainfall. Remember, there are 3 types of rainfall. The first one is convectional rainfall, and second is relief rainfall, and the third one cyclonic rainfall. Let us see what are they. So, the first one is convectional rainfall. Here you can see the diagram. During the day, when air comes in contact with the hot surface of the earth, it gets heated, becomes light and rises up. Okay. So, during the day, when air comes into contact with the hot surface of the earth, it gets heated and becomes light and rises up. So, on reaching the upper layers of the atmosphere, when it is reaching up, it cools down. It cools down. The water vapor in it condenses and rainfall occurs as a heavy downpour. Okay. So, it is sudden and often accompanied by thunder and lightning. So, this kind of rain is called convectional rainfall. Okay. It occurs throughout the year in the equatorial region. and where it is called 4 o'clock rain. Great. So, convectional rain is also known as 4 o'clock rain. And next one is relief rainfall. Here you can see the picture. Relief rainfall. This type of rainfall is also known as orographic rainfall. Orographic or relief rainfall. So, it occurs when a range of mountains or hills, lies in the path of moisture bearing winds. Okay. So, the warm moist air is forced to rise when it meets an obstruction. So, it was flowing smoothly. When obstruction came, it is forced to move or forced to rise up. So, as the air moves upwards, it starts cooling. Once it is up, it starts cooling. The water vapor in its condenses and rainfall occurs. The windward side, that is the side of the mountain facing the winds. Okay, facing the winds here. So, winds are coming from here, no. So, the side of the mountain facing the winds receives the maximum rainfall here. The other side of the mountain or the leeward side receives very little rainfall, and it is known as what? Rain shadow region. This area is known as rain shadow region. So, the monsoon rainfall in India is an example of relief rainfall. And the next, cyclonic rainfall. Here you can see. In a cyclone, when winds from all sides blow towards the center in a spinning manner, different air masses meet together. Okay. When warm air meets cold air, the warm air being lighter rises above the cold air. So, warm air rises above the cold air. Okay. Then the rising warm air cools in the atmosphere. While it is moving up, it cools and condensation takes place, causing rainfall. Okay. So, this type of rainfall is common in the tropical seas and in the mid latitudes. So, let us have a recap of our chapter in the form of a mind map. So, our chapter is elements of weather and climate. So, in this chapter we have discussed the temperature of the atmosphere, factors controlling the temperature, then atmospheric pressure, factors influencing atmospheric pressure, then permanent pressure belts and winds, planetary winds, then humidity, condensation, precipitation and rainfall. So, let us see the first. We have discussed that the factors or the elements of weather and climate are temperature, pressure, winds, humidity, precipitation, sunshine and cloud cover. So, the first one is temperature of the atmosphere. So, what is temperature of the atmosphere? The temperature of the atmosphere can be defined as the degree of hotness or coldness of air. Then the instrument used to measure temperature is called a thermometer, and factors influencing or factors controlling temperature. So, the temperature of the atmosphere is not the same everywhere. So, the various factors which control the temperature of the or temperature of a place are latitude, altitude, distance from the sea, then winds, ocean currents, etc. And atmospheric pressure can be defined as the force exerted by the column of air due to its weight at a particular place on the earth's surface. And what are the factors affecting the atmospheric pressure or influencing the atmospheric pressure is the factors which affects the atmospheric pressure are altitude, temperature and water vapor, and also the permanent pressure belts. So, there are 4 major pressure belts on earth, and the first one is equatorial low pressure belt, second is the subtropical high pressure belt, then third is the subpolar low pressure belt, and fourth was the polar high pressure belt. And what about winds? What is wind? The horizontal movement of the air is called wind, and winds always blow from high pressure areas to low pressure area, and they are named after the direction from which they blow. So what about the planetary winds? So these planetary winds blow in the same direction throughout the year, right? And thus they are also called what? Prevailing or permanent winds. Then they are of three types: the trade winds, the westerlies, and the polar winds, and few more periodic winds, then local winds, etc. are there. So what is periodic winds? Blow in a particular direction during a specific time of the day or a season. Then local winds, it blow over small areas for a short duration and are associated with weather changes. And variable winds, so variable winds blow for a short duration and change their speed and direction frequently, right? Then what about humidity? The amount of water vapor present in the air is called humidity, and humidity of air is expressed in two ways: absolute humidity and relative humidity. Then next was condensation. When the temperature of saturated air falls, the water vapor in it gets converted from the gaseous state into the liquid or solid state. So this process is called what? Condensation. Then different forms of condensation are what? Clouds, dew, frost, fog, etc. Then precipitation, continuous condensation of water vapor in the air results in the formation of minute droplets of water. So when these droplets join together, they form bigger drops, then which become too heavy to float and start falling down. So this process is called precipitation. And the last one is rainfall. When the condensed water vapor in the clouds falls down in the form of water drops, it's known as what? Rain. So there are three types of rainfall: convectional, then relief, and cyclonic rainfall. So learn the chapter well, stay home, stay safe, bye bye.